Hi, everyone. My name is Jamal Al-Karaki. I am a professor of computing systems, specialized more into disruptive technologies, including cybersecurity, artificial intelligence, machine learning, Internet of Things, blockchain, and applications of those on different domains and different businesses. Today, I want to focus more on one of the areas which I am interested in, and working on this is the power of intelligent wireless sensor networks. And I will talk a little bit more about their applications and give you some case studies, a little bit more about the challenges, and as well as some future research areas of interest. That is an area for collaboration. So basically, we will compare first to traditional wireless sensor networks and how intelligent wireless sensor networks are different, talking a little bit more about their applications, about challenges, and how we can integrate software engineering and machine learning into the intelligent wireless sensor networks. And then we'll discuss further the challenges and the future directions. If we go back in time, the topic of wireless sensor networks has been of interest for the past maybe 20, 30 years. And there were advancements in the MEMS technology that allowed us to build small, tiny, integrated wireless transceivers and use those to sense different types of physical parameters. And then a network of those sensors can be created called the wireless sensor network. As you could see here, there are different types of modern sensor nodes. These are just examples, as you can see over there. Now, this sensor node, as we know, is limited in terms of energy, in terms of computation power, in terms of storage power, transmission range, and the bandwidth of communication. And that's why the need for a network of those sensors, a dense network of those sensors for different applications is widely needed. This is just an example of one of the sensor nodes, which has been printed on a circuit board and its technical specifications. Definitely today we are seeing more types of tiny, little bit more powerful due to the advancement in computational power and chips. And therefore, these sensor nodes are becoming of things that can communicate over the internet and allow for different applications. Now, the overall architecture of a sensor node is, as you could see here, there are three layers actually. There is the physical layer where the wireless channel is used to communicate. There is the MAC layer, and then there is the network layer, and then there is the application layer. Now, applications normally running on the sensor node to gather data and maybe perform some analysis and make decisions when, those nodes are autonomous and they are performing in the field, as you could see in this example here, where sensor nodes are distributed in the sensor field, and there's a base station which allows them to gather the data from the sensor field. Typical problems in wireless sensor networks actually include two major problems, which is the connectivity and the coverage. So normally the connectivity, we want to make sure that there are no nodes that are isolated in the field, and those nodes, they have at least one communication channel established with a neighborhood sensor. And typically we have some sensor nodes very close to the base station where the data is being gathered. Now, if the base station is not there, then this sensor network will become autonomous, and sensor nodes, they will collectively work together to make a consensus on a decision for the best interest of the application they were created for. The other problem, which is the coverage, this is a measure of quality of service of the sensor network. We want to observe that, okay, there is a certain event that is covered for the entire duration where this event is running over there. So we need not a sensor node to be to die before the event is over. For example, intruder detection, animal or fire detection, and so on. So we want to make sure there's an optimal coverage of the distribution of those sensor nodes. And this is a problem of optimization. So the coverage normally depends on the range and sensitivity of the sensing nodes, as well as the location and density of the sensing nodes in a given region. Now, there are two cases for the coverage. One is the worst case, where there is a lowest coverage, and normally when we do analysis, we want to assume a worst case coverage so that we can decide if additional sensor nodes will be needed at a certain point in time. While the best case coverage is normally we want to, a friendly user can navigate on those areas and without an issue. And therefore we are not, we don't care about if a node will die because there are more than one node is covering that area. And therefore we can navigate those areas easily. Now, the architecture for the wireless sensor networks, either layered architecture, as you could see the figure to the left, as well as the clustered architecture, the ones to the right. And the difference between those two is that whole set of nodes in the layered architecture is in one domain. They are in one cluster, but different layers. While in the other one, we have different clusters, but in the same layer. So, for example, we put the red sensor nodes in one cluster, the blue ones in another cluster, and the green ones in another cluster. Now, normally in each cluster, there's a cluster head. In the layered architecture, it is the base station. While in the cluster architecture, in addition to the base station, we have designated cluster head selected or elected from one of the sensor nodes. Now, definitely, as we mentioned, because those nodes are limited, then we need to create a network of those sensors so that we make sure there is a coverage and we have redundancy among the nodes and they are accurate because they need to collaborate and combine their data to increase the accuracy of sense data and so on. Now, these are the typical applications of sensor networks. And I think at this point, it's just a refresher for something that we already know for the past maybe 10 or 15 years. Now, what's new? Due to the advent of machine learning and artificial intelligence, how can we enhance and overcome the limitations of sensor networks and improve their functionalities in different applications? Like, for example, environment monitoring, healthcare, smart cities, some applications in the desert, some applications in water, oil pipelines, machinery, and also try to find out something in the middle of a desert, how we can detect an intruder, detect a moving object, and so on. Okay, so let's move on now to the introduction to intelligent wireless sensor networks, where we define intelligent wireless sensor networks is an advanced version of a traditional wireless sensor network, but this one has more capabilities of collecting, processing, and transmitting data, and they will leverage sophisticated algorithms, machine learning techniques, and software engineering principles to enable the intelligent decision-making at the network level. So this is the definition of an intelligent wireless sensor networks. Now, the key characteristics of intelligent wireless sensor networks include autonomy. As I mentioned before, Like the sensor nodes here, they operate autonomously, and there is no human intervention, and they will make decision based on the collected data locally. These networks, normally they are adaptable, and therefore, and if the environment change, also the functionality of those networks will change by adjusting their operation and configuration and in response to the changes. They are intelligent by nature because they are employing intelligent algorithms or techniques, such as machine learning. And whatever data they collect, they will analyze it, extract some insights from it, and then make decisions to optimize the network performance and the energy efficiency. And energy efficiency in particular is a very critical here resource because these are nodes with that is very tiny, small batteries, doesn't last for long, and therefore intelligent algorithms and optimization techniques will be employed. It has a distributed processing, and therefore decision-making actually is based on a distributed sensor nodes in the network, and therefore for large volumes of data, this group of sensor nodes, large group of sensor nodes will be able to process them, and there is no need for centralized processing. Because of that, they are scalable, and they can accommodate an extended number of sensor nodes and adapt to the changes. Now, whenever we design an intelligent wireless sensor networks, there are some design principles that we need to consider. I'm listing here 8 of them, and I think most probably these are straightforward design principles for any intelligent system, but there are some specific design principles for the wireless sensor networks given their limitations. For example, the energy efficiency, for example, how they can fuse the data fusion, and how they can interoperability so that they can integrate with other systems. In addition to that, we have the scalability so that we can incorporate large number of sensor nodes. There is a reliability because if a group of nodes, they die or they run out of energy resources, still there are some other nodes who will take over and they can deliver and perform the functionality needed. Now, let's focus more on the use of software engineering and AI or machine learning in the wireless sensor networks. The obvious use of software engineering here is the efficient resource management through intelligent algorithms. So normally we come up with a software architecture in optimizing performance, and this software architecture will optimize the performance of the wireless sensor networks by providing a structured framework for designing, implementing, and managing the software components. If this is implemented right, then this will result in many advantages. One is the optimal resource utilization. Another one is the energy conservation, which is a very limited resource. For example, the software could do something like duty cycling and sleep scheduling, and this will help minimize the energy. Bandwidth optimization, they can run the resource management strategies like data compression, prioritization, routing protocols to optimize the bandwidth used for delivering the data. Adaptability, flexibility, we talked about this before. Fault tolerance, reliability, and scalability is something that the software architecture can facilitate and can result in optimization of the overall system performance. When it comes to machine learning in intelligent wireless sensor networks, so machine learning will allow us to develop algorithms that will allow us to enhance the capabilities of traditional sensor networks so that they can now analyze and interpret the data more intelligently. And this comes up to 3 components. One is the data analysis and predictive maintenance and anomaly detection. So in the first one, the algorithms will deal with large volumes of data, and then they will do clustering, classification, regression, so that they can identify patterns, trends, and correlations within the data. And such insights will help us to analyze the environment we are monitoring, for example, climate change, if there is temperature changes, humidity changes, air quality changes, and so on. For predictive maintenance, this is where dealing with failures that can happen in the network. So we can predict if something is going to happen to the sensor nodes, and therefore we can detect and indicate a potential failure. So machine learning models can forecast this and will allow us to extend the lifespan of the various facilities that is being monitored by the intelligent wireless sensor networks. And lastly, the security aspect is to detect anomalies from the normal behavior in the data collected. So this will indicate, for example, security breaches, unusual events, or some potential faults that we need to deal with, especially such as unsupervised learning algorithms like isolation forests or autoencoders. This will automatically identify anomalies in real time. Now, the challenges that normally is presented by the intelligent wireless sensor networks is three. One is overcoming the resource constraints, and this is done by optimized algorithms, enhancing communication reliability using machine learning-based routing protocols, and managing data overload by using intelligent data processing techniques. Now, quickly, I'll go through two case studies on how intelligent wireless sensor networks can be used. First one is the environmental monitoring system. Description of the system is there. And I'm showing now how the software engineering and machine learning can be used with this case study. Actually, it is not different from what has been described before. The environment monitoring system, we want to see or monitor and analyze certain parameters like air quality, water quality, soil moisture, temperature, for example. So basically, we will deploy sensor nodes across different locations. And these sensors now, they will measure the environmental variables. And the software engineering will help us ensuring reliability, scalability, and maintainability, while the machine learning will allow us to analyze the data and make accurate predictions by employing unsupervised learning techniques. Now, results of this will be improved environmental monitoring, early warning system, data-driven decision-making, and cost and resource efficiency. The other one is healthcare monitoring system. Similar to that one, we want to implant those sensors in the patients. So we continuously monitor such as vital signs, heart rate, blood pressure, glucose level, activity level, and so on. So software engineering principles now is crucial here. It will allow us to handle large volumes of patients' data securely and efficiently. Machine learning will allow us to, again, analyze the collected data, detect any anomalies in the patient's vital sign, and then make decisions or intervention alerts to deal with such cases. Now, for future directions, there are many things still to be done in the area of intelligent wireless sensor networks. There is like edge intelligence, swarm intelligence, energy harvesting, cognitive radio, and blockchain integration. All of these have different problem set that can be looked at as a pathway for further research when it comes to the use and applications of intelligent wireless sensor networks. Other application areas also like smart cities, healthcare monitoring, environmental monitoring, precision agriculture, which is a very interesting area that currently also we are looking at as a different thread of research with my group. And then the industrial Internet of Things. Now, opportunities for further integration of software engineering, machine learning, advanced data analytics, autonomous systems, optimized resource allocation, self-adaptive protocols, security, and privacy. So to conclude, what we have done in this presentation, we talked about the intelligent wireless sensor networks, their challenges, and how the integration of software engineering as well as machine learning can help in fostering various applications of it. We looked at two case studies. We have seen how powerful those intelligent wireless sensor networks can play a role and the importance of integration software engineering and machine learning, as well as potential for innovation and impact in various domains. Thank you very much for listening to this presentation, and hopefully you can have a chance to discuss questions and answers later on. Thank you.